So, now we are going to tell about the semiconductors. You will be hear about the things called semiconductors. Did you hear about the topic semiconductor?
Yes, sir. Another family.
Huh? Huh? What would?
Semiconductor.
No, it's not in the fan. It will be there in all the computers, PC, laptops, cameras, motherboards. In all motherboards is the semiconductor. Okay, semiconductor. What is meant by semiconductor? What is conductor? Conductor is the conduct which one conduct the electricity. In opposite to its insulator.
Non-current.
Huh? Huh?
Insulator will not conduct current.
It will not conduct the current, insulator. That means conductor is one, semiconductor. Semiconductor means that things it's depend upon the semiconductor. The moment semiconductor means the conductor is the one which conducts the current. Semiconductor means which retards the flow of electrons. Which retards the flow of electrons. So, semiconductor, the moment semiconductor means it will retard the flow of electrons. It will retard the flow of electron means retard the flow of electron means what will happen now when I can retard the flow of electron? Do you understand the point? Conductor is the one which conducts the flow of electron. Semiconductor is the one which retards the flow of electron. Retard the flow of electron when I can get that retardation of the flow of electron. This I already teach you in the AC current. See, again I am teaching the same.
Voltage drop.
Voltage potential. I want to retard the potential means delta V should be, you have to control the delta V. That is the change in the potential. If I change the potential means that it will be retardation. This is one of the way to get the conductor. One of the way to get the semiconductors. So, this is a basic behind this semiconductor. So, the semiconductor is conductors are divided into three types. Conductors are divided into three types. Conductors. No, conductors. First one is metal, second one is semiconductor, third one is insulator. Okay. So, in the semiconductor, so in the metal, resistance will 0. If resistance is 0, what will happen? Resistance 0 means what happened to the metal? It will show the conduction. Semiconductor, the resistance is half. That means it shows half conduction. Then in insulator, resistance is full, 1. That means it will not show the no current, or it will not show the conduction. That is no current. Okay.
Insulatorல current show பண்ணாது.
Semiconductorல half conduction இருக்கும். இதுல full current, full conduction இருக்கும். Conductor. Full conductor இருக்கும். Full conduction, that's why it's called metal. Rho is equal to specific resistivity. Specific resistivity. So specific resistivity is equal to 1 by conductance. So which is for metal it is 10 power minus 2 to 10 power minus 8. For semiconductor is 10 power minus 5, 10 power 5 to 10 power 6. For insulator is 10 power 11 to 10 power 19. Ohm meter. Specific conductivity is 10 power 2 to 10 power 18, 7 meter inverse. 10 power 5 to 10 power minus 6, 7 meter inverse. 10 power minus 11 to 10 power minus 19, 7 minus meter inverse. Specific resistivity. Rho is specific resistivity. Sigma is conductivity. This is specific resistivity. This one is conductivity. I give some example also. This one you know very well. What is it is? You know very well what it is. No. You have to tell me now what it is. This one what is it is?
Metal.
For metal what will be the example? Okay. See, it is you can't.
Copper.
It should be copper. It should be copper. For metal means it should be.
Copper.
That's all. For semiconductor means it is silicon and germanium. You know, right? You are aware of this or not? You are aware of it. You are aware of it or not? No. For semiconductor means obviously it is silicon and germanium. For this one, insulator is glass. Why? What happened? What?
5, 10 to the power 5 minus 10 to the power inverse 6, correct, sir?
No. 10 power minus 2, 10 power minus 8. Next one 5 to 6. 10 power 6, 5 to 10 power 6. 10 power 11 to 10 power 19. Specific resistance for insulator is very, very high. So, it will not conduct current. Semiconductor will conduct, but it will soft. Yeah, so this one is 10 power minus 10 power minus 10 power minus 2 to 10 power minus 8. So average of it, what will be the average? Average.
Which one, sir?
This one. So 10 power minus 2 to 10 power minus 8. So average will be 10 power minus 5. So 10 power minus 5 ohm meter. This one is 10 power minus 5 to 10 power minus 5. 10 power plus 5. No, 6, no, approximately you keep it as 10, 5 itself. 5 and 6 has no difference. 10 power minus 5, 10 power plus 6. So it's almost 10 power 0. 10 power 0 is almost,
Half of the current.
No, 10 power 0, any number power 0 is 1.
1.
So it's almost 1. Semiconductor is almost 1, but here it is 10 power.
-5.
Here it is 10 power minus 5. Here average, just average 10 power minus 5. Here 10 power 0. Here it is 10 power 11 to 10 power 19, which is 10 power 15. 10 power 15. So this is an average value, specific resistivity. So which has the highest value here?
10 power 15.
10 power 15. That's why insulator, it will not conduct the current. Then you go for semiconductor, which is 10 power 0, which is 1. So it will conduct
Half of the
half of it. Then 10 power minus 5. 10 power minus 5 nothing but 1 divided by 10, 0, 0, 0, 0. So 1 divided by 1 divided by 1 divided by 1, 0, 0, 0, 0, 0, 5. So 1 divided by 5, which is 1 divided by 5, which is specific resistivity with 1 divided by 10, 1 lakh, almost I think see 1 divided by 1 almost 1 lakh. Okay. So if I 1 divided by 1 lakh means out of 1 lakh 1 part of it. So very low resistance, no resistance or 0, almost 0, nothing but almost 0, almost 0. So that's why the specific resistance 0 means for metal it will conduct the current. Over. First sigma is conductivity. Conductivity 10 power 2 to 10 power 8. So 2 plus 8 average is 10 power 5. So 10 power 5, here it is 10 power 5 to 10 power minus 6. Okay. So average is 10 power 0. 10 power 0 to 10 power minus 6. Minus 6 you can take it as minus 5. So 10 power 5, this side 10 power 5 and this side 10 power minus 5. So 10 power into 10 power 5 to 10 power minus 5 is 10 power 0. So any number power 0 will be 1. So here it is 10 power minus 11 to 10 power minus 19, which is 10 power minus 15, which is very, that's the specific conductivity is for insulator is 10 power minus 15, which is very low value. This means it will not conduct at all. So this and this value also 0, almost 0. So you can't imagine about conduction in insulator. Only in semiconductor and metal you can replace the things, but here it is semiconductor. So that's we have to just this value is sufficient. I think conductivity is also you need no need conductivity. The specific resistivity is sufficient. So what I am getting is specific resistivity. This one is 0, this one is 1, this one is 10 power 15. So this value is sufficient. That means it shows that semiconductor is
shows half of the conduction.
Half of the conduction. This one is very high conduction. This one is a very high conduction because
Full conduction.
full conduction. It will show full conduction. This one will show the half of the conduction. This one is no conduction at all because what is specific resistivity value? The specific resistivity value is 10 power 11 to 10 power 19, which is 10 power 15. Okay, next go for, did you finish this?
Yes, sir.
Everything, you taken everything?
Yes, sir.
Example? Then we go for energy bands. Energy bands. Energy bands. Energy bands. BANDS. Energy bands. Each electron will have a different energy. Each electron will have a different energy. Each electron will have a different energy level. Each electron will have a different energy level. So, this different energy level, this different energy level with continuous energy variation, this different energy level with continuous energy variation is called energy band. Is called energy band. The energy band which includes energy level, it's of two types, valence band and conduction band. Valence band and conduction band.
The energy band include energy level.
The energy level with continuous variation, with continuous energy variation is called energy band. With continuous with continuous energy variation is called energy band. With continuous each electron will have a different energy level. First one is each electron will have a different energy level, and this different energy level with the continuous energy variation are called energy band. Okay, so this energy band are divided into two types, which is valence band and conduction band. So it is two types, valence band and conduction band. Okay. Valence, it's two types, valence band and conduction band. And so the energy band which includes the energy level of the valence electron. The energy band which includes energy level of the valence electron. Energy band which includes energy level of the valence electron is called the valence band. The energy band which includes the energy level of the valence electron is called the valence band. The energy band which includes the energy level of the valence electron, which includes the energy level of the valence electron, is called the valence band. Okay, the electrons above the conduction band. Now conduction band. The conduction band is the one which accepts the electron from the valence band. Conduction band is the one which accepts the electron from the valence band. Conduction band is the one which accepts the electron from the valence band. Electron from the valence band, and normally conduction band will be the above the valence band. Normally valence band will be conduction band will be above the valence band, so that it can easily accept the electron from the valence band.
Normally conduction band
Will be above the valence band, so that it can easily accept the electron from the valence band. So for that purpose, conduction band will be normally empty.
sir, once more please. Normally conduction band will above the valence band.
Ah.
So
That's all. Normally conduction band to accept the electron, to accept the electron, to accept the electron. To accept the electron. Okay. So and to accept the electron, and conduction band will always be empty. Conduction band will always be empty, so that it can access this already I told you, no, second point. What is second point? What is it?
normally conduction band will above the level, above the valence band, so accept the electron.
So that it is easy to accept the electron. So that it will be easy to accept the electron. So that it will be easy to accept the electron. So that it will be easy to accept the electron. Then third one. Huh? Huh?
It is always be empty.
It is?
Always be empty.
It is always be empty to accept the new electron from the valence band. It will be always be empty to normally, not all the times, normally it will be always empty to accept the electron from the valence band. Empty to accept the electron from the valence band. Normally it will be always empty to accept the electron from the valence band. Okay. So, the lowest energy level in the conduction band, the lowest energy level in the conduction band lowest energy level in the conduction band and highest energy level in the valence band, highest energy level in the valence band, lowest energy level in the conduction band, which is EC, which is EC, right, which is EC. Lowest energy level in the conduction band is what? The lowest energy level in the conduction band is EC. Okay. Highest energy level in the valence band is EV, of EV, of EV. So, the difference between EV, EC and EV is called EG, which is energy band gap, energy band gap, energy band gap. It's called energy band. It's called energy band gap. Energy band gap. So, this energy band gap could be small, 0 or large. No, I am telling. EG, this EG could be small, 0 or large. Okay. So, how many points you got?
1, 2, 3, 4, 5, 6.
Okay. So, 6 point is no. You understand that question? It's easy only. Did you understand that point?
Yes, sir.
No, you tell 1 point, I will explain. You tell me one by one, I will explain. Okay. What is first point?
The conduction band is one which can accept the electron from the valence band.
Conduction band is a one. Yeah. This is the upper one is a conduction band. This is empty now. This is filled. If valence band is filled here, it has lot of electrons. So, this will accept the electron from the conduction band. This is the conduction band. EC will accept the electron from the valence band. Okay. Then second.
Normally conduction band will above the valence band, so accept the electron easily.
So easy to accept the electron. So the conduction, this is the valence band. Conduction band is above, so it can accept the electron from the valence band easily. Next, third.
Conduction band is empty to accept the electron from the valence band.
So this will be always empty, so that this accepts electron from the valence band. Next.
The lowest energy level in the conduction band and highest energy level in the valence band, EV.
The lowest energy level means this one, this point. This point. Highest energy level means this point. The lowest energy level in EV, highest energy level in the EC.
Highest level in EV.
No, highest level in the
Lowest is EC.
lowest is EC, highest is EV.
The difference. So the difference between the EC and the EV is the EG.
EG, which is
energy band gap.
energy band gap. So GG, which is energy band. EV, difference between EV and EC is called energy band gap. Then that's all.
EG would be small, 0 or large.
Large. That I will explain in now. You taken this?
Diagram.
You take this salt. Okay. So, valence band is valence conduction band, valence band. Valence band low, what is the lower surface of the valence band? Lower surface of the conduction band. Huh? Lower surface conduction band is EC. Higher surface of the valence band is EV. Equal to energy gap is equal to EG is equal to 0. So, EG equal to 0 means what happened to the energy gap now? 0 means what? No gap. EG is equal to 0 means there is no gap. That means valence band coincided with the conduction band. That means the electron in the valence band is occupied by the now conduction. What happened to the conduction band? What happened to the conduction band now? No, what happened? Yeah, it's not accepts the electron. It filled the electrons. It's filled with the electrons. Now you go to the valence band. What is the specific resistivity for metal? For metal, what is the specific resistivity?
minus 10 power minus 2.
What is conductivity? What is specific resistivity for metal?
Rho.
Yeah, rho.
10 power minus 2.
10 power. Okay. Average you can take. Average what is the value? 10 power minus
5.
10 power minus 5 ohm meter. That means it has very low resistance, very low resistance. So, since it has very low resistance, the conduction band and valence band are overlapped. So, the electron in the valence band is moved to the electron in the
Conduction band.
electron to the conduction band. So, the electron will flow very rapidly. That means that it will show the conduction. So, what is the example?
Metal.
Which metal?
Copper.
Yeah, copper. So, the copper that we are using is everything we are in motherboard. You can see the stepwise staircase, near to staircase, that's a big board will be there. So, that's a main board. From main power supply, see how this is the first floor. In the first floor, how many rooms? This one room, there second room, then office third room, then fourth room. So, I think 4 room is there in this corridor itself. So, 4 room will be divided from their main force only. All the current will be carried only via copper. So, it will be conductor. So, this one is a metal. Okay. Another is, second is insulator. The band gap is the band gap is the 3 electron volt. It is the 3 electron, it is greater than 3 electron volt band gap. Distance between the valence conduction band and valence band is greater than 3 electron volt. And for semiconductor, it is for third one, semiconductor is now the energy gap is almost 0 here, Eg is equal to 0. So now we go for semiconductor. Semiconductor means the electron volt is greater, that is it has a energy gap of around 3 electron volt. 3 electron volt. But if Eg is greater than 3 electron volt means what here for insulator? This one is 3 electron volt. Eg is greater than 3 electron volt means what?
No conduction.
No conduction is different. This is second point. No conduction is second point. Point 1, Eg is greater than 3 electron volt. Eg, that is gap. That gap is greater than 3 electron volt means what?
More, less gap.
Huh?
More gap.
Huh? Yeah, it will be, it have more gap. Okay, it will have more gap. That's why. So what is physically means? See, you are telling point 2 and point 3, 2 and 3. I am asking point 1, which is very important. Eg is greater than 3 electron volt. That means what?
Not fully with gap.
Huh? Eg greater than 3 electron volt. That means what?
0.
How 0? Eg greater than 3 electron volt. That means what? That means it could be 4, it could be 5, it could be 6, it could be 7, 8, 9, but it is not 3. It is not 3, it is not 2, it is not 1. Okay? But it could be 4, 5, 6, 7, 8, 9, 10. Then it could be 100 also. It could be 1000 also. It could be 10,000 also. If the band is 10,000 electron volt greater than 3 electron volt means how will it conduct current? No, that's the point. That only you have to tell me. See, it's a insulator is Eg is greater than 3 electron volt. So now semiconductor 3 electron is greater than Eg. If 3 is greater than 3 electron volt means the greater than 3 electron, the maximum value is 3. The 3 is greater than electron volt. What is the now possibility? Only 2 possibility.
1 or 2.
1 or 2. So it could be 1 or it could be 2. That's all. That means which is very small. Here it is 0. That means no problem. Here no problem at all. Eg is equal to 0 means the metal valence band coincides with the conduction band. Okay, so Eg is equal to 0 here. Here Eg is so 1 or 2, which is very small. So this is what the conduction. This is what you have to tell me. Then everybody knows that insulator means no current. It will not conduct current. Then what you told me is another point.
Gap is very
Gap is very high. That's why it's called insulator. Gap is very high means if Eg is greater than 3 electron volt means I can put Eg is equal to 1000. If I put Eg is equal to 1000 electron volt, what will happen? The gap is very different, though there is no conduction at all. So, semiconductor, now we are going to see semiconductor. Semiconductor is of two types, intrinsic and extrinsic. So, semiconductors are two types, N type and P type.
Semiconductor is two type, N type and P type.
No. Semiconductors two types, intrinsic and extrinsic. Intrinsic and extrinsic. Extrinsic is divided into N type and P type. Intrinsic and extrinsic. Intrinsic means INTRINSIC. 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 SIC. Extrinsic is EXTRINSIC. Extrinsic. So, extrinsics are two types, P type and N type. Okay. Now we go for intrinsic semiconductor. Intrinsic semiconductor. So, intrinsic semiconductor, number of free electron is equal to number of holes. Number of free electron is equal to number of holes. Number of free electrons is equal to number of holes. Okay. So, that means I am having 4 electron. Okay. How many holes I am having here? How many holes I am having here? 4 holes. Why I need the 4 holes? That means why you need 4 holes? 4 holes is a one which will occupy the electron. So, this is the summation. Okay. Okay. So, the holes will occupy the electron. So, the excess electron n is equal to h. So, excess electron or excess electron or excess hole is equal to excess electron is equal to excess hole is equal to 0. There is no excess electron because n is equal to nh, 4 electron is there, 4 holes is there, all electrons are occupied in the holes. So, the number excess electron is equal to excess hole is equal to 0. taken? Then extrinsic semiconductor. Extrinsic. So extrinsic semiconductor. Now you have to tell me. You written right? Extrinsic semiconductor are two types. Okay?
P type and N type.
N type. What is the N type and what is N type and what is the P type? N type is nothing but N type is nothing but N type is for electrons and P type is for holes. N type is for electrons and P type is for holes. In N type is N type, P type, Ne is greater than NH, NH is greater than Ne. That means what? Now, number of electron
Greater than the
number is greater than the number of holes. That is, number of electron is greater than number of holes means excess electron is where? Huh? No. Number of electron is greater than number of holes means number of excess electron will be present in where? Excess electron will be
present in the hole.
no, excess electron will be present here.
Sir.
Here number of holes is greater than number of electron. So excess hole will be present in the P type. That's all. You understand this concept now?
Yes, sir.
You understand? No, first you understand.
Here electron is present.
Ah.
Excess electron is present. Here excess
Hole is present. That's all. But in extrinsic semiconductor, no, this is extrinsic, no? Intrinsic.
Semiconductor, there is no hole. There is
There is no holes and no there is no. So excess electron is present. Excess hole is present. Or
yes, sir. Sir, what is the meaning of hole?
hole is the one that will accept the electron.
Not proton.
Not proton, no, that's different. I am having what is current? What is current?
Of electron.
Flow of electron. I am taking some 5 electron. I am taking what is current? Current is I is equal to dq by dt. I am taking this I is equal to flow of electron, flow of charge or flow of electron. So with the potential V, this one is a potential delta V. Okay, current is flowing here. If the current has to flow, you need number of holes present in there. Then only the current will, the electron will move. So the holes nothing but holes current is, so if the current is nothing but this, there is a holes. Holes is the one which accepts the current electrons, or it occupy the specific position. hole specific position. If there is if the number of electrons should be equal to number of electron is equal to number of holes, then only current will flow. Current will flow. You take this, you take the everything, take this. Or so this is valence band and this is conduction band. Difference is
Energy gap.
energy gap. So if this it will be for semiconductor, it will be for metal it will be, there is no Eg, this Eg will be 0. So this and this will coincide. For insulator this will be very high, this Eg will be very high. For semiconductor it is moderate. So what I am doing it, I am shifting this, I have to shift it, okay. So in the I have to shift it. What I am doing is I am shifting creating the valence band which is very near to the conduction band, okay. Valence band which is very near to the
Conduction.
which difference is ED is difference is 0.1 electron volt. So this and this is what is for a for semiconductor, what it is value for semiconductor Eg. Eg, what is the value of Eg for semiconductor? 1 or 2. It could be 1 or maximum itself we can take 2 electron volt, okay. Just it could be 2 electron volt, okay. It's a 2 electron volt. Now I am decreasing it. Now I am decreasing it. Now the difference is 0.01 electron volt. So the difference is between valence band and conduction band is difference is 0.1 electron volt. Now in p type I am decreasing, I am shifting it to lower band. Now this is what is it is EV. For EV and EC difference is how many electron volt? 2 electron. But I am shifting the conduction band here. Okay. So now what is the shifting the conduction band here? So what is the difference between this EV and EC? 0.01 electron volt. This one is okay. You take it as 1 electron volt here. Just put electron volt. It is 1 electron volt and 2 electron volt. You can take it as 1 electron volt itself. Okay. So EG for semiconductor. Okay. So this is one is now 0.01. 1 divided by 0.01 how much? 1 divided by
0.0.
how much difference?
It's something 0.00.
100. It should be 100 times. So the electron volt is which is 100 is decreased to almost 100 times. 100 times. How it is decreased? Because of valence creation. Because this is now what is this bond? What is this one? This one, no, this one is valence band. What is this band?
Energy gap.
That means you didn't understand. No, you didn't understand.
Conduction.
Conduction band. This conduction band is shifted to here now. If conduction band here means the valence band and conduction band energy gap is Eg, which is 1 electron volt. Now I am shifting the EC here. That is p type semiconductor. Shifting it, energy gap is now 0.01 electron volt. Normally for initial for it is for semiconductor it is 1 electron volt. For p type it is 0.01 electron volt. So 1 divided by 0.0 electron volt will be 100 times decreased. So the resistance decrease, the energy gap decreases means what will happen now? Conduction will be more. Conduction will be more. So the p type semiconductor is a one which has now again this also same n type semiconductor. If for n type semiconductor this one is conduction band, this one is a valence band, difference is Eg. Okay. Now I am shifting now what is this value? This one is valence band. So the valence band and the conduction band difference is Ed, which is 0.01 electron volt. So now again the conduction will increase. Conduction will increase. Or flow, not flow, current will flow, conduction will increase. But here the conduction will increase because here it is gap is very high of 1 electron volt. Here it is 0.01 electron volt. So 1 divided by 0.0 is equal to 100. 100 times now the gap between this and this is 100 times decreased. Here the gap between this and this and gap between this and this, it is increased to very small, which is 100 times. So the conduction will flow, the conduction will increase, current will flow. So that is the p type and n type and p type. Okay. PN junction, PN junction. PN junction. What is P? P type. P type. N is N type semiconductor. The P type semiconductor is important for transistors. It is important for transistors. Okay. So, in this the two important process occurs during the PN junction is, first, what is the first point I told? PN junction is a
P-type semiconductor important for transistor.
no, not P type, PN junction. PN junction. PN junction is the is a important is important device for is an important device for transistor. Okay. So, the two important process occur during the formation of PN junction is two important process that occurs during PN junction is diffusion and drift. Diffusion and drift. Diffusion and drift. What is diffusion? Diffusion means moving. Electron will move, and drift means staying stabilizing. Hole will stabilize. So,
Diffusion means electron will move.
diffusion means diffusion and diffusion and drift are two important. What is I told? Diffusion and drift. Two important processes in the PN junction. Okay. In that, first one is diffusion. What is diffusion means? Diffusion by which the electron will move. Drift is the one by which the electron will occupy in the hole region. Hole will be stable in one part. Hole will not move. Okay. You understand the concept now? Only electron will move. Hole will not move. Hole will be stable forever anywhere. So, the electron is moving will be occupied by the drift, which is hole. So, how many points you got? What is that point?
PN junction important for transistor. Two important processes that occur to the PN junction is diffusion and drift. Diffusion is electron will move. Drift is electron will move to the hole.
No. Diffusion is the one by which electron will move.
Sir.
Drift is the one by which holds the which by which the holes will be holes is fixed. Holes will be fixed. That's all. The holes will be fixed. The hole will be fixed. That's a drift. Holes is fixed. Holes is fixed. Okay. When hole diffuses from P to N, when hole is diffuses from P to N,
When hole diffuses.
from P to N, P to N. Or no, first we will go for this one. When electron diffuses from N to P. No, you just take it out this point. Just take it out this point. When electron diffuses from N to P. When electron diffuses from N to P. Why electron diffuses from N to P? Electron will not diffuse from P to N. Then what will diffuse from P to N? Why electron will diffuse from N to P? Why electron will diffuse from N to P? Because you understand my question now.
N type is electron, P type is hole.
N type is electron, P type is hole. So N type will have an excess electron. So when the N and P attached, what will happen? Electron will flow from N to P. So when electron flows from N to P, a positive charge is developed on the N type. A positive charge is developed on the N type. A positive charge is developed on the N type. Okay. Now we go for second one. Second one, what is second one?
When a hole diffuses from P to N.
What is first one? What is first one? Yeah, when electron diffuses from N to P. Second one will be when the hole is diffuses from P to N. When P is attached to N, what will happen? Hole will diffuse to P to N. So when the hole is diffused from P to N, you understand this concept now. First one is N to P. Electron will because N will have excess electron, so N will diffuses to P. Okay, now P is diffused to N. P will have excess hole. So now hole will diffuses to P. Okay, did you write this?
Yes.
Okay. So when hole is diffuses to P, it will create the positive charge in the. It will create the positive charge in the. No, it creates a negative charge on the. No, what is first one? When N is connected to P.
Positive charge is developed from the N type.
N type. So now negative charge will develop on the P type. Negative charge will develop on the P type. So this junction is called PN junction. This junction is called PN junction. Okay. Now it comes. Now PN junction has has asked to undergo to apply now PN voltage is applied on two portion, which is forward bias. Okay, PN junction is two types, forward bias and reverse bias. Forward bias and reverse bias. No, it's of two types. No, two types. Two types is how will you write? Two types. Forward bias, BIAS, and reverse bias. So in the forward bias, you can see the external voltage is applied to the voltage applied, that is positive is P type, positive side P type
Sir, forward bias, the external voltage is
applied in such a way that P is connected to the positive terminal of the battery. P is connected to the positive terminal of the battery and N is connected to the negative terminal of the battery. P is connected to the positive terminal of the battery and N is connected to the negative terminal of the battery. Okay? Okay. So, positive terminal is connected to P type, negative terminal is connected to the N type. As a result, depletion region width decreases. As a result, depletion region will decrease. Depletion region will decrease. Okay. Now you go for reverse bias. In reverse bias, how will you attach the thing now?
P junction is connected to the
Negative terminal and the thing will be the positive terminal. That's all. You attach. So now what happened? The first one, the depletion region decreased. Here it is depletion region increase. So the current flow will be which will be higher?
reverse bias.
No, depletion region is increased gap. The depletion region is a gap, type of gap, which is increasing, forward or reverse. Depletion region which is increased here.
Reverse.
Depletion increased means current flow will be less. You understand the concept? No. You
Depletion
is a depletion is a gap that is increased. So the number of flow of electron will increase, or decrease?
Decrease.
Yeah, the flow of electron will decrease. If the gap is wider means the flow of electron will decrease. So the current flow is greater in the
For
forward bias. Current flow will be greater in the forward bias. In the reverse bias it is less. That's all. Okay. So the dynamic resistance is a dynamic resistance is a small change in the voltage to the small change in the current. Small change in the voltage to the small change in the current. Dynamic resistance is small change in the voltage to the small change in the current.
Sir, RD means dynamic resistance.
Dynamic resistance equal to delta V by delta I.
Okay, sir.
So now application of junction diode as a rectifier. Application of the junction diode as a rectifier.
Yes, sir.
Okay. Application of the junction diode as a rectifier. The rectifier is the one to rectify the alternating voltage. Rectifier is the one to rectify the alternating voltage. Hence it is called as rectifier. Hence it is called a rectifier. Okay. So if the alternating voltage is applied across the diode in series, if the alternating voltage, now first you take the definition. You take the definition. And what is the definition?
Rectifier is one. Rectifier is the one. Rectify the voltage. Hence, it is called rectifier.
Yeah, correct. Now, if the alternating voltage is applied across the diode, if the alternating voltage is applied across the diode, if the alternating voltage is applied across the diode, if the alternate voltage is applied across the diode, A pulsating voltage, a pulsating voltage,
Spell that, sir.
pulsating, P-U-L-S-A-T-I-N-G, pulsating, P-U-L-S-A-T-I-N-G, pulsating voltage will appear across the load. Pulsating voltage will appear across the load in a off cycle. In a off cycle.
Appear across the load.
Load in a off cycle.
Yes, sir.
When the diode is in the forward base. When the diode is in the forward base. When the diode is in the forward base. When the diode is in the forward base, and this is called off-way rectifier. This is called off-way rectifier.
Yes, sir.
If the voltage output given corresponds to both, if the voltage output given is given both in the positive and negative direction of the cycle, is given both in the positive and negative direction of the cycle, is given both in the positive and negative direction of the cycle, it is called, it's given positive and negative direction of the cycle, it is called full wave rectifier. Okay.
Yes, sir.
So it's a full wave rectifier. So now what is a off wave rectifier, full wave rectifier? You got it right? Both you got it right? Full off wave rectifier and full wave rectifier. So in the same series, Zener diode.
Xeno diode.
Zener diode is Z-E-N-E-R-D-I D-I-O-D-E diode. Zener diode. Z-E-N-E-R Zener diode. Is a 1. Zener diode is a 1. Zener diode is a 1. When the applied potential reaches the potential reaches the breakdown voltage, when the applied potential reaches the breakdown potential, when the applied voltage reaches the breakdown potential, breakdown potential or voltage, breakdown. So okay, put it as breakdown voltage. So breakdown voltage, there is a large change in the current. Yeah, so this is Zener diode. called Zener diode. Then optoelectrical junction, optoelectronic junction device, optoelectronic junction device. Optoelectronic junction device. Optoelectronic device is a one by which you can see that photons are generated. No, not like that. Electrons are generated, by which the electrons are generated, electrons are due to presence of external rays, due to presence of external rays, due to presence of external rays. Okay, it's of three types. Due to presence of external rays, due to presence of external rays, due to presence of external rays. Okay, so these are just three types. It is of three types. So first one is photodiode. Second is LED, light emitting diode. First is photodiode. Photodiode is used for dictating the optical signal. First one, photodiode, no? It is used for dictating the optical signal. No, first type you write. Oh, okay. Oh, third type I didn't tell. Photovoltaic cell. Third one is photovoltaic cell. Photovoltaic cell or solar cell. Okay. So the photodiode is used for dictating the optical signal. It's used for dictating the optical signal. LED will convert electrical energy into light energy. LED will convert electricity into light. Or you put LED will convert current into light. Example, current into light. Example,
These lights are
yeah, tube light also. All the lights now, ordinary lights are slowly vanishing. In another 10 years, I think everything will be LED only. Okay. Then solar cell. Solar cell, you know, a conversion of sunlight into electricity or electric power. Electricity means you can produce electricity. Electric power means you can attach any light to it. It will burn, something like that. We both are same only, right? Obviously. So conversion of electricity radiation into sunlight into conversion of sunlight into electric power. So did you understand?
yes, sir.
So do you have any doubt in this?
No, sir.
Okay. Okay. Where you can find the solar cell? Solar cell, where you can find? Not some apartments, in the street. In the street full of in the street full of in the street full of in the street, in the main GST road, main GST road, all the street is made up of the solar cell. The solar cell they attach to the light. The solar cell they attach to the light. So in the night time it will burn continuously. Night 6 o'clock to early morning 6 o'clock it is burning continuously in the main GST road. Main GST road they fix it, automatically fixed. Automatically 6 o'clock it will they switch on, and the power they take from the sunlight during 6 to early morning 6 o'clock. Evening, early morning 6 o'clock to evening 6 o'clock they will take that power, and it will glow in the night time. They fix it, they program it around 6 to evening 6 o'clock to early morning 6 o'clock. That's all over. Okay. Take some break, again we will meet. இன்னும் முடியல, இன்னும் break முடிச்சிட்டு again we continue. It's a very big lesson. When we started 10 o'clock we started, no, to 12 o'clock. So again we will continue after some time.